Shut up and sit down.
Hi everybody, welcome to the stream. I am KiteCraft, and today we're going to look at using multiple displays on an ESP32 with the TFT espi library. That's right. Now if you look right here, you will see that I already have an example running. We'll take a closer look in a minute, but what we can see there was we have a top display where it looks like it's running sort of a matrix style. In the middle we have Pong, and in the bottom is just a bit of a gauge that goes back and forth. Now what you're seeing there, all three of those are actually examples from the TFT espi library. I've just adapted them to a different type of display manager. This gives them the ability to update at an interval and allowing all three screens to update a little bit of data each cycle. The trick behind this is that these use the SPI interface. Now if you're familiar with the Bodmers TFT espi library, you'll understand how we hook all of this stuff up. And we're going to take advantage of the fact that all of this is based on the SPI interface, and we're going to be able to use that to our advantage to actually run multiple displays. Let's have a quick look at, or a close-up look at what we've got going on here. In this example, I have three displays. These two are 2.2 inch, and this one is a 2.8 inch. This one also supports touchscreen. All three of these displays use the ILI 9341 display driver. Now these displays are very common. You can buy these pretty much anywhere, and they use the SPI interface. There's another type that you can find which use a more complicated setup. Well, it seems more complicated because there's more connections. This uses like an 8-bit parallel output. Now, I haven't tried using multiples of these yet, but I actually think it might be possible because these also use the same CS pin that we're going to use to our advantage. So I only have one of these, so I can't actually look into using multiple though. But what we see here is three SPI-driven displays, all connected in series back into my microcontroller. And the top, never mind this little line here. That's actually just because I haven't peeled off the display protector. This is brand new. Now you can see that this is scrolling very smoothly. There's absolutely no flicker on any of these, and this Pong is moving very, very quickly. In fact, I had to slow this down a lot to make it look good. Otherwise, it was just whipping along and it's way too fast. So it really is easy to get nice, stable graphics across multiple displays with a single ESP32 microcontroller. All of this is running off of a single core as well, using Bodmers TFT espi library. So let's have a look at that. First of all, if we go to Github and we'll go to Bodmer, and you'll see right there is the TFT espi library. Now this is version 1.2. If we go and have a look at the .h file, this is version 2.13. Now you can get the same, well you can get the TFT espi library through Arduino, but if we actually have a look, sketch, include library, manage library, I already had that open. Come on now. There we go. TFT underscore espi. You'll see this version here is rather old, 1.4.2. So I recommend you skip this and just go straight to GitHub and get the latest version. It's definitely worth it. There's sprites and really neat stuff happening in here that you'll like. Anyways, some of the examples we're looking at today can be found on my own GitHub. I am KiteCraft. Go to github.com/KiteCraft. There's a multiple TFT displays. The triple TFT is what we're looking at over here, down below me. The triple TFT is in fact this thing right here, so you can set it up yourself if you have three displays. If you have only two displays, you can still use it. You just won't see the data on the third display. And there's also a basic double TFT, and we're actually going to build this example because you'll see how simple it really is to work with multiple TFTs. Now, if you've worked with the TFT espi library before using one of these similar displays, you'll know just how easy it is. All you have to do is go into that user setup.h file. Wherever you've installed your libraries, there's a library called the TFT underscore ESPI. That's the library that you're using for all of this. And then there's inside there is the file called user setup.h, as we see I've got listed here. You know from experience that it's very easy to use this TFT library. You just simply, if you're using the ILI 9341 like I am, you'll notice that one's already set up. You can go ahead, take care of whatever he's got set up in there, but then you can come down here and you can define your little SPI lines and what pins they're connected to. MOSI, or MISO, MOSI, clock, you've got chip select, DC, and reset. Now, a quick refresher for you. There are two main buses that we use in this little microcontroller world dealing with Arduino type of programming. We have the I2C interface, which uses basically the two lines, I guess it is, SDA and SCL. And all the devices on that bus, you can have multiple devices, they all have an address. So when data is being sent out, they're sent to a specific address, and each device listens on those lines, and when it sees data with its address on it, it goes ahead and picks it up. Now, the bus we're using here is called SPI, or what's it stand for? I have to look it up. I keep forgetting. Where are we? Yeah, Serial Peripheral Interface. Now, it's a little bit different. It requires a few more wires, but it has some other advantages to it. And both I2C and SPI, they both have, or I2C and SPI, they both have pros and cons to them. But these devices use SPI, and we actually can take advantage of that in a way that we wouldn't be able to with the other bus. In SPI, we're basically dealing with 4 lines. Sorry, I'm just looking for this. No, that's not the one I wanted. We're going to go back here. We're basically dealing with 4 lines. And if we look at how our microcontroller or how our display is set up, it looks a lot like this. So these pins on these displays are all laid out in this order. At the bottom, we have our VCC and our ground. Now VCC, I'm running just on 3.3 volts. So we have our VCC, and up here we have our LED light. This is our LED backlight, and I'm just feeding that a strict 3.3 volts as well. Now you can see on my breadboard that I've actually got just small yellow wires connecting the 3.3 volt lines to the power rail, and then I have green going from the ground to the ground rail. Now that leaves us with several lines for our SPI interface. And our SPI interface consists of the MISO, the clock, MOSI, and then the CS lines, which I'll talk about in a minute. Now, all of your devices that are on your SPI bus connect to those 3 lines, MISO, clock, and MOSI. MOSI is master out, slave in, and MISO is master in, slave out. So you have bidirectional data happening on all of those. And the clock, SCK, is of course how you sync up the timing between all your devices. Now, whereas on the I2C interfaces, everything gets an address, the SPI interface actually uses the CS pin, which is more simply called chip select. So all of your devices are all on the same bus, but each one gets its own CS pin. Now you'll notice the way I've got these laid out, we have a whole bunch of yellow wires going straight from my top display. We've got these yellow wires that jump down to here, and then they jump down to here, and then they jump down to here. So everything is connected in serial. That's the MISO, clock, MOSI, DC, and reset lines are all connected directly in series from here to here, from here to here to here to here. But it's the MISO, MOSI, and SCK lines that make up the SPI interface. The DC line this simply stands for data command. When our TFT driver is talking to the display, for example, during the init, it'll actually set that pin into a particular state, whether or not it's sending data that we need to display, or if it's actually sending commands for the TFT, for the ILI 9341 chip. It can set registers and do a whole bunch of things. So that DC is controlled by our TFT driver. And we want them all connected because we want to manage our displays all at the same time. And then, of course, we have our reset pin. And there's different things you can do with the reset pin. I've actually connected them all in line and to an actual pin on my microcontroller. Why not? But then we get to the magic of the SPI. That is the fact that each individual device has its own chip select. Now, normally, when you were setting up a single display for use with the ESPI library, you're going to set just this one value, define TFT CS. You can also set up touch screens, and that works just as well. So this is how the TFT driver actually communicates with the display. Even though you'll have multiple items on your bus, you actually use that CS line to talk to just one particular item. And that's where my little oscilloscope comes into play. Let's just move this back here. Try and get everything back into focus. And you might notice my little toy oscilloscope over here. Now, it's not very great, so you'll see it misses lines sometimes. But it's actually connected to the chip select pin for this display. Now, on an SPI interface that we use on these microcontrollers, the SPI interface is called active low. Well, I'm sorry, all of these devices are called active low. What that means is if that CS pin is held low, or 0 volts, that device knows that the data that's coming on the communications line are meant for it. If the line is held high, then it's the device is inactive, and any information on the bus is ignored by that device. So you'll see this very regular pulse happening here. That's because this lower display is actually only updating every 30 milliseconds. If we have a quick look at its code, you'll see this little bit, this one line right here in the header file, update screen interval 30. So that means we're actually only updating this needle every 30 milliseconds. If we didn't, it would just be flying really fast back and forth. But if we go too slow, then you'll see it kind of stuttering. So but you actually have a wide range of intervals in there that you can deal with. So I went ahead and picked 30 milliseconds. The actual example that this is based on, which is called the TFT Meteor Linear, I believe it uses 35 milliseconds, but I sped it up just a little bit. If we go back to our oscilloscope, right now it's set to 20 millisecond divisions. If I zoom in a bit on that, so these are 10 millisecond divisions, and you might not be able to see it very clearly on this camera, but if I count the lines from the edges, it's 0, 10, 20, 30 milliseconds. And we can see what's happening is that normally the CS pin is held high, and then it's pulled low when we do the update, when we actually we block out the needle where it was and we draw the new needle position. And it happens really quick, and you can see that's when that pin is pulled low, and then it's released back high so that we can continue along. Now, if I switch this over to our Pong screen, you'll see its update frequency is a lot faster. I'll try and zoom in a bit. This is on a 30 millisecond or 10 millisecond per division. Let me zoom in a bit on this. Whoops, wrong way. 5 milliseconds per division, 2 milliseconds per division. So that's 1 millisecond per division. That's for the Pong screen. Now, why is it actually doing that? Well, if we look back at our code, if we look at our Pong, we'll actually notice that, where is it? Its update interval is set to 0. I'm actually trying to update this as fast as possible. However, the display manager does have to pause every time through its loop. Otherwise, the ESP32 will throw this watchdog timer exception, and the whole thing crashes and reboots. So I have to pause it at least every millisecond. Now, because of that, we'll see the CS line our chip select line is actually being pulled low every 1 millisecond. But again, if you notice, there's actually more time spent idle than active. Now, idle is when it's at the top. So you look at how wide that it is at the top, and it is definitely wider up at the top than it is at the bottom. So even though this is a 1 millisecond per division level, so every time it drops down is 1 millisecond, it's only taking less than half a millisecond overall to do everything it's doing, and then it goes back up, and it's spending more than half a millisecond idle. Now that's the chip select pin for the middle screen. Now let's have a look at the chip select pin for the top screen. Oh, before we go, note how wide the bottom of that spike is. So that chip select pin is being held active all of that time. Now note how wide it is. Like I said, it's just under half a millisecond. Now, that's the Pong screen, and you can see that all it's updating is those two paddles and the ball. And then when it goes across the middle, it might have to update a little bit there, but look at how much time it spends in the update. Now let's go look at the matrix screen. Okay, so it's hard to pick it up. It's not a great oscilloscope. This is a 5 millisecond per division, and you can see that it's picking it up about every 5 milliseconds or so. But what you really notice, if I go down to the 1 millisecond, the same division that we were at earlier, so that's the 1 millisecond per division. That's the same scale that we were looking at Pong. Now, first of all, you can see that it's not updating that fast. It's updating. We can see there's a spike way over there. There. Try and move one into place. Okay. So I've got this one balanced directly on one of the intervals, and this is 1 millisecond interval. Now we saw that Pong was updating every millisecond, and it was spending a long time, almost half a millisecond, actually active. However, our matrix screen, which looks like it's doing a lot more work because it has to like redraw the entire screen, we can see that it's not updating every millisecond. It's updating only every 1, 2, 3, 4, 5, like 6 milliseconds. And the update, you see how narrow that is. The update is happening much, much, much faster. Here's the big difference. This is using a sprite, and it's scrolling the sprite. This is actually using the TFT direct draw onto the interface. So this does a lot of work in memory and then just does a real quick update to the screen, which is happening really fast. But these TFT draws are much slower as they have to update the screen, and this is why one of the advantages for the new TFT SPI library is to use those sprites. So overall, you can see we actually have spare cycles on this core. We're not at max capacity. So how do we do all this? Let's get into some code. First thing we do, we open up our user setup file from the TFT SPI library. And whatever method you're using in here for your SPI interface, comment out the CS. What we're going to do is we're going to manage the chip select pin ourselves. Remember how I said all of these devices can live simultaneously on a single SPI bus, but we use the chip select pin to specify which device we're talking to. Now, if we give the chip select pin to the TFT SPI library, it's going to control what device it's going to talk to. And so every time we do like a sprite push or a TFT draw or fill, something like that, it's actually interacting with the screen. So that's when the TFT library will actually want to use a CS line. But we want to handle our own CS line. That way we can actually, whenever we call a TFT dot, fill or draw string or fill circle, we're actually going to decide which display that action is done on by deciding which of the CS pins we're going to pull and manage ourselves. And it is really, really easy to do. We start off with a basic sketch, our basic empty sketch, and we go ahead and we include, whoops, I'm looking at my wrong screen, SPI .h and pound include TFT underscore E SPI.h. Hopefully I spelled them right. So I've got my notes over here that I'm just following along with. TFT. There we go. So that's what you would normally do in any situation when you're setting up the TFT SPI. Those are the first steps you do. Now, normally what you would do right after that is TFT underscore E SPI TFT equals TFT underscore E SPI. Right? You create your TFT object, and then that's what we're going to go ahead and use. However, we need to do something else. We need to actually set up our own chip select pins. So what we need to do is we're going to create two little variables and call it first screen, CS, and second screen, CS. Let's go have a look at what's going on down here. So while all of our lines are connected together, we've actually pulled out the CS pins from each display and set them up on its own pin on the microcontroller. So the top display is connected to pin D15. This display in the middle is connected to pin D21. And this pin down here, or this display at the bottom, its CS pin, its chip select pin, is connected to pin D22. So we're going to use those chips or those pins ourselves. Now, the way the SPI interface works, as I just shown you, is the CS pin is normally held high. And then when we want to write to that display, we just pull that pin low. And then anything we do with the TFT object, or the sprites that we create from that TFT object, are going to happen on whatever display we have in the low state. So first thing we need to do is actually define our chip select pins. In this case, I'm using pins 21 and 22. So that's it. That's what our big first difference between what you would normally do and what we're doing here. Now, in our setup, we actually need to set up our pins just like you would in any other situation where you're using digital pins. We need to go ahead and pin mode them. First screen CS output digital, is that lowercase? Yeah, digital, right? Hi. Second screen. Whoops. There we go. So now we have, oh, second, did I spell that wrong? There. Now we've managed our own chip select pins. We've set them to output modes and we've set them to high. We don't need to worry about pull-ups or anything like that on these. We're always going to be driving it directly, so that's okay. And we don't need any resistors anywhere either on this interface. So we've got two, I'm going to use two displays in this example. So we're setting up 2 pins and we're going ahead with our standard TFT ESPIs, no difference there, except we've commented out that TFT CS pin. We're handling that ourselves. There we go. And the first thing we do is we set them to output and we set them high. Now, trick number 1. This is where things kind of might be a little bit tricky for the first people that are coming here. However, once you see what I do here, it's all going to click for you and you go, oh geez, that's how you do it. And then you're just going to go off and running. Now, normally what you would do, if you were only using one display, you would normally just come in here and you would go tft.init, right? Now, what this does is it initializes not just a TFT object with a bunch of variables like those pins and things like that. It actually communicates with your display and sets up some parameters there. So making this call is doing a lot of work both with the TFT object itself and on the actual TFT. So what we really need to do is we need to set our pins where, because we're going to actually do some whoops, second screen. We actually want to do some work on our TFT. We are going to set these to low. We are going to call init. Now, you notice I'm doing this to both pins simultaneously. What this means is, remember we were saying on the SPI interface, if the chip select pin is pulled low, then the device is going to listen to the data that's on the bus. Now we have multiple devices on here. We need to initialize all of those devices, so we do it simultaneously. We pull all of the pins low, we call init, and then we pull all our pins high. Now we've set up our TFT object and we've set up all of the displays simultaneously on that one call. Go ahead, we're going to do one other thing here. I'm going to go TFT, set my text size. There. Now, again, all TFTs have actually just had their text size set simultaneously. Now what we're going to do is we're going to update one screen and then we're going to update the other screen. Now, something you'll notice here, I'm actually just going to make a difference. We went ahead, we set our pin mode, and then we did this high, because high is our inactive state. So normally this is what you would do. However, you can see we're going directly back to low state. So we could just call these directly into low and not even worry about these, right? We could just do that even, and we'd be good. But for the sake of this example, and just to keep everything separate for you, we're going to go ahead and do that, which is what you would normally do. And then later on, you would actually do your init by pulling everything low and then pulling everything high. Now, we're ready to go. Now we're going to do some updates to our first screen. So we want to pull our first screen low. And just to make sure I don't miss it, we're going to go ahead and pull it high. Whoops, I got the wrong one. Now inside that low and high, what we're going to do is we're going to set our rotation to be 1 on this display. And then we're going to go ahead and we're going to fill it with red. And then we are going to do a print, tft.print, hello world, I'm display display number 1. Okay, that'll work. Now let's take this. We're going to go ahead and copy this. We're going to paste it here, but we're going to do this with our second screen. We're going to pull its CS pin low, and then we're going to set it high once we're done. So anything we do between setting it low and high, all of these TFT calls are now directed at the second display. So we're going to change this to display number 2, and let's change its color to green. And let's change its display to 0. Now, that's another interesting thing that we've got going on here. I actually want to manage these screens with separate rotations. Now, if I didn't, what we could really do is just up here in our first initialize, we can set our rotation there. And that would set all of our displays to the exact same rotation. And therefore, I wouldn't need to do any of this. However, I want to have my displays with different rotations. I want one of them being in regular portrait mode, and I want the other one to be sideways. If you look what's going on here, try to get this to focus, both of these displays are portrait mode, but this one is actually at a different rotation. Normally your matrix is streaming from the top down, but here it looks like it's actually streaming from the right to the left. That's because I've actually changed the rotation of it. Normally, that screen you should be looking at it this way. That's because we're managing its rotation, its set rotation separately from everything else. I'm just putting my oscilloscope back to, whoops. All right. Sorry, I'm just putting it back to measuring the CS pin for this lower needle. It updates every 30 milliseconds. So here I've got my the resolution is at 20 milliseconds per interval for the time. So. Okay, back to what we were looking at. So I've set up 2 CS pins, pins 21, which is this one, and pins 22. So it's going to be for these 2 displays. And then on our first display, we're going to set the rotation to 1, and we're going to write hello, or we're going to set background of red. Oh, you know what? Let's put some background color of red on here. What do we need to do? Okay, now let's go ahead and plug this in. We got my USB cable here. You can see what I'm doing down here at the bottom. We're going to plug the USB into the esp32. We'll go ahead and upload this code. Okay, so we're going ahead and uploading it. You can keep an eye on what's happening on the bottom. Now, what we're expecting is going to happen is it's going to fail. Oh. Oh, did I forget to put a number in there? There. No use telling it to set the text size if you don't tell it what the size is, right? Now, what we're expecting to see is these devices will reboot, and then the middle screen will be red, and it'll say number 1, and the bottom screen will be green, and it'll say number 2. We'll give it a reboot. I'm going to switch over to the overhead camera, and there we go. Look at that. That's all there is to it. All you have to do is manage the CS pin yourself. It's that easy. Okay, now let me show you something that we can do with that. All right. I'm going going to go ahead and comment that out. And I'm going to comment that out. Now down here in our loop, let's see here. Let's go, first of all, let's just create a bagel variable. Int loop counter equals 0. No, wait, no. Let's do this. Bool display choice equals true. There, let's do that. Now down here in our loop, I'm going to go ahead and put a delay 2000 in here, just a 2-second delay. And what did I just call that variable? I called it display choice. We're going to flip it down here. Display choice equals not display choice. Now here we go. If display choice else. Okay, that was weird. Oh, you know what? Okay, loop int pin. Okay, pin equals first screen CS. Else pin equals second screen CS. Nope, second. Okay, so now let's just take this and we're going to go ahead and we are going to do this. We're going to pull that pin low. Pin. And then we are going to do some work and then we're going to set that pin high. Now, what's our work? TFT.fill. You know what? I get spoiled. I'm going to cheat. I'm going to just cheat TFT fill fill rect. What do I need here? I need an X, which is, I'm going to go with 20. I need a Y, which is 20. I need a width, which is 100. I need a height, which will be 20. And I need a color, which is a uint 32T. So I'm going to go back to here. I'm going to put int color. Color equals TFT red. No. You know what? Screw it. Let's just do this. Okay, so the only reason why I did that was so that I could take this. I like the autocomplete of the IntelliSense, and I'm going to come back over here. There, fill rect. And what's the color? We'll go with TFT black. Is that the color? What was the color that I was dealing with there? Was it the text color or a background color? It just says color. Alright, well, whatever. We'll just say black. And then we'll set the pin high. Oh, we got to fill it, right? Dash TFT set cursor. Yeah. Cursor 21 by 21. TFT.print. Hello, display number. Oh, you know what? Let's do this. Okay, so here what we need is if display choice. Oh, well, actually, just use. I'm just going to stick the pin in there. So let's do a print F. Display number %I. Pin. What's your work? No, that's not what I wanted to do. I wanted to do something else. Oh, right. That's what I was going to do. Int loop counter. You'll see, this is going to be cool. I'm going to take my loop counter. plus if loop counter is greater than 1,000. Loop counter equals 0. There. Oops. Loop counter. There. So what we should see is odd numbers on one display and even numbers on the other display. We'll just go ahead and compile that. I actually don't know which one's which though. Why didn't it like that? Color. Oh, that's because I don't need that. I was going to try something different, but we don't need that. Now, all you can see here is that we're just simply choosing what select pin to pull low. We do our actions on it while it's low, and then we set it high. Pin. Pin. And that's how you use multiple devices or multiple displays with TFT, SPI. It is literally that easy. I took a long time explaining this because I wanted to draw the video out, but there we go. What are you doing there? Did I forget something? Yeah. Oh, if I'm filling that with black, I need my text to be a different color. Oh well. I should have done this with TFT yellow. Because we're probably... Oh no, it sort of worked. Yeah. And there we go. So you can see display 106, 108. What did I start my loop counter at? Oh, I started it at 100, that's why. I'm looking at that, I'm wondering, why is it starting at such a high number? Because I started it at 100. It should start at 0. My bad. We'll let that rebuild again. But you can see exactly what's happening there is we're just simply selecting our pin to pull, and off we go. And it's just that easy. So we have a look here, and we simply... we write our pin low, or we set our pin low, drive it low. We go ahead and do our TFT work, and then we set our pin high, and then we clean up. So we want to try and do as much work as we can. What happened? There we go. We want to try and do as much work as we can in memory. That's why you'll want to use sprites most of the time. And then you just drive your pin low, do your work real quick, and then drive your pin high and finish off, and it's really that easy. There we go. You can see we're actually alternating the updates on the two different displays. 10, 12, the even numbers are at the top, the odd numbers are at the bottom. Let's speed it up. Let's turn this up. Let's turn this up to, let's say, just 500. There. I'm going to speed that up to just 500. Hurry up and build. There we go. Push the button. Now you'll see those numbers pull up real quick. Yeah, there we go. And you can see on the oscilloscope, if I zoom out a bit more, wow, it's barely even registering on there. But as you can see, we're updating 52, 54, 56, and this one is updating. Those are bad colors. Let's try a different color there. Let's try blue there. I'm going to change the color from green to blue on that screen just so it's a little easier to see. But yeah, that's really all you have to do, is you're just managing your own chip select pins. Remember, in the user setup file, comment out the chip select pin, and then in your own code, do your own highs and lows, as it were. There we go. A little easier to see there, isn't it? Now, you can, of course, get much more complicated than that, and that's where the other example in this comes from. Here we have the triple TFT, and this is using a small example of a display manager. Now, the display manager takes care of all of the work of timing, of running in the background and changing screens and whatnot, and then you simply define your own little class that actually does what you want it to do. So this is taken from the example, this splash screen is taken from the example of the TFT meter linear that comes with the TFT SPI library. So let's go ahead and upload this one. We're going to go ahead and upload this code right here. This is from in my GitHub in the multiple TFT displays example. This is called triple TFT. Now you can use this with double if you only have two, and I'll show you how easy that is in a minute. But we're going to go ahead and update this, taking its time. And push the button. Now the code uploads. We'll switch over to the other camera. Now what you're going to notice, while this matrix screen is building, everything is running a bit slow. And then once the screen is finished building and it's only scrolling, everything speeds up. Now I haven't optimized the building portion of that, but we could tweak a couple of numbers and make it a lot smoother. But it's a good example of the difference between of just how much time you want to spend in each particular update interval. You want to minimize the amount of time in an update interval. That way you can share your time between the screens. So in this particular example, you'll see in setup we include our display handler and this queue item. We're going to set up a task handle. We create our display handler, and we actually run the display handler on the other core, on core 0. That way our loop is still free to handle all sorts of other work, and the display handler simply runs on that other core, and it takes care of all of the processing necessary to switch between the screens and does all that work. And it does it in a rather clever way. If we look at the display handler, you see first of all there's just a small struct where it defines our pin, screen rotation, and then a couple of function pointers. And then of course there's just a few other commands in here. And the display handler, when it loads a new screen, and you can create as many screens as you want, this is where the touchscreen comes in handy. It just takes the functions, some functions that you define, and points them to those function pointers that are in that structure, and then it acts on those. So when we go through an actual update, if we look at its run command, what it's doing here is just simply looks at to see if it needs to dispatch a command, which is either an update value, or if not, it just goes through its list of known displays and calls the update on interval. And it'll do this on each loop, which is really, really, really fast. So fast that I actually have to slow it down. This delay for 1 millisecond, otherwise the watchdog timer complains. It's really quite funny. So each class has its own little update. Let's have a look at Pong. And then there's this interface file called Pong Functions. The display handler is actually pointing these functions, where to go? These are from the functions file, and the functions file just simply acts as an interface with the actual class. So inside our class, we'll have a function called, where is it? Update screen on interval. So every time our loop goes through, it updates this. So we have to decide, do we actually want to update? So we make sure we're only updating at a certain speed. That way, otherwise our screen just goes way too fast. So this is defined in our header file. There's a reason for that, but whatever. So normally you have your own update, and then we go ahead and we prep this display. So this is my function where we actually go ahead and we pull our CS pin low and we set our display. Here's our function, our prep display. What it does is it drives the pin low and it sets our rotation so that this particular update is going to go to that pin and it's going to be in the right rotation. Then we go ahead and we do all of our work, and then we complete the update, which in this case is just simply to drive the pin high. That's what we're going to do. So each of these classes, so this is our pawn class, here's our matrix screen class. It has an update screen on interval, where it's simply doing a very similar thing. Prep the update, which is pull the pin low, set the rotation. It does its little magic, and then it completes the display by setting the pin high. So each of these screen classes can share all of this work just by doing the chip select updates. So that's how you run multiple displays on an ESP32 with Bodmers TFT SPI library. You just manage the chip select pin on your own. And I didn't have my desktop up for any of that. I suck. Alright, so we're coming up time to wrap this up. I hope that was informative. It was way too long and drawn out. I know I've got to learn how to keep things shorter and brief. So maybe I'll do an actual video instead of a live stream about this as well. But if you have questions, feel free to ping me. This is all it takes. So thanks for watching. Subscribe, turn on notifications, and you'll see more videos from me coming up in the future. And I hope to see you then. Hopefully this made all the sense you need. Just make sure you're managing your own chip select pins, and that's how you drive multiple displays with a single user setup.h file. Alright, bye.
Shut up and sit down.